Today we have another guest speaker, James Ryan, Dr. James Ryan, who I met a few years ago at the International Conference for Interactive Digital Storytelling. He is a graduate of UC Santa Cruz, which is one of the big hubs of game-based and interactive story-based research. Your advisor was Michael Matthias and Noah, or just Michael?
Yeah. I was co-advised. Yeah.
Okay. By Michael Matthias and Noah Wardrop-Fruin, both of whom will read several papers from both of those authors throughout this semester. And James has done some really amazing work on emergent storytelling systems and the curation of stories. But also the main, so part of it, I just wanted James to be here because he's an incredible researcher in our field. But also, at one point, you did a really extensive research project on the history of early interactive narrative systems. And right now in the class, we're basically going through this sort of early history. We just did Tailspin and Author, and we did some of that early work on grammars. So what better person to talk about this sort of early history than James Ryan. So please welcome James Ryan. James, thanks for being here today, and please feel free to take over the screen whenever you'd like.
Sure. Yep. It's absolutely my pleasure to be here. You are all in great hands, having Stephen Ware teaching this class, and I've seen the syllabus, and it's a very good syllabus. I hope you're enjoying the class. I'm sure you are. It's a dream kind of class that's just not offered at most institutions in the U.S. currently. Hopefully that's not the case. Hopefully in 50 years, it's obviously there's AI for interactive storytelling at every class. Every institution rather. Okay, I'm going to share my screen here. And so here's what I'm going to do today. And I assume you're seeing slides. Here's a really early timeline of completed systems prior to 1980, basically. 1980's Author, though that wasn't completed, and it's very confusing whether it was ever completed, but then a dissertation came later. Author was important, at least for the ideas in that paper that you've read. But this is kind of the really early stuff. Most of this super obscure, except for Tailspin. Tailspin is, I'd say, Stephen, that Tailspin is probably the most famous story generator still. And certainly at this time, it's the most famous story generator. I've got stuff where I can talk about any of these, and I don't know if you touched upon them. I assume not, because most of these are really obscure. But what I'm going to do is really dive in on this first one. This is the earliest computer story generator of which I'm aware. First effort in computational narrative of which I'm aware. Generating or interactive storytelling or what have you. This isn't interactive. It's a story generator, as we'll see. But this, to my knowledge, is really one of the first. And there may be something earlier comes up, but 1960s is really early for computers. This was developed on a mainframe that you'll see some pictures of in a moment. Possible there was stuff in the 50s. Not possible there was stuff in the 40s. I don't think the ENIAC was used to generate stories. It could store like one 20-digit number. There's just no way. So 1960s super early. This might be the first. It's certainly the earliest known. So what I'm going to do is, I have this talk that I've given on it before, and I'm going to give that talk. It's kind of a performative talk, and so it doesn't really make sense for an audience of 6, but I figured it'll still be informative, certainly, and maybe a little bit entertaining. But this is like a 15-20 minute talk about this earliest system, Saga 2. And then when that's over, we can pop into Q&A and discussion. I'll be happy to clarify about anything or expand upon anything I talk about with regard to Saga 2. And then I do have like some materials for these other early systems that we might like to talk about as well. So without further ado, I'm going to dive into this. It'll be about 15-20 minutes, and then we'll get a little more interactive and back and forth for the second half. The year is 1960, and the MIT Centennial is just around the corner. CBS Television notices the occasion, and they decide that they'll celebrate it. They'll make a television program. They'll call it Tomorrow, and it will be about the future that MIT scientists are working to create. This is Douglas T. Ross, professor at MIT. He's busy coining phrases like computer-aided design or CAD. And this is Thomas H. Wolfe, television producer at CBS. He's worked on shows like See It Now with Ed Murrow, and now he's writing and producing Tomorrow. Wolfe and Ross get lunch in New York, and they're discussing whether computer-aided design would make for compelling television. Ross fears that it won't, he confides. It's too esoteric, he tells Wolfe, and the mood goes dour, and the lunch is about to end. But then Wolfe poses a wild question. Could a computer write a Western, he asks Ross. The plots are so formulaic, he says, so could a computer write a Western? Ross says he'll have to think about that. And the lunch ends, and then a month passes when finally Ross writes to Wolfe to say, yes, a computer could generate a Western, I think, but it would have to be pantomime, no dialogue. Wolfe is nonetheless enthused, and it would appear that a peculiar collaboration between MIT scientists and CBS television producers is underway. But then Claude Shannon, the Claude Shannon, for reasons I have not been able to determine, attempts to persuade Wolfe against the idea of airing computer-generated Westerns. Don't do it, he says. But ultimately and thankfully, Claude Shannon is unsuccessful because CBS televised computer-generated stories in 1960, and 10 million watched. This is a project that I've been undertaking to excavate this system called Saga 2, going through materials at archives and finding everything I can anywhere I can look. And this effort has been made possible by Don Knuth, if you can believe it, the Computer History Museum, MIT Archives and Special Collections, and especially Jillian Smith, who's collaborating with me on this. Now, this wasn't the first time that computers would generate literature in a broad sense. In 1952, Christopher Strachey, working with Alan Turing, produced computer-generated love letters. And in 1959, Theo Lutz in Germany produced computer-generated poetry. But this would be the most ambitious undertaking in computational media to this time by a mile. And Ross had to invent everything from scratch. His early sketches are remarkably well formed. The stories will take place in a robber's hideout and center on a shootout between a robber and a sheriff. The plots and the characters' behaviors will be structured along 6 places of action. There's a corner, a table and a chair, a window, a door, an area outside the door, and an area outside the window. Actions center on props. There's money bags, a bottle of whiskey and a glass, and of course, the guns. Now, each of these props affords certain actions that the character can take using the prop. You can pick up, put down, count, or gloat over the money bags. You can pick up, put down, pour, or drink from the bottle and the glass, and you can do gun things with the guns, and there's certain actions that you can take no matter what's in your hand. This is Harrison R. Morse, aka DIT. He's a master's student at MIT, and he's going to lead programming on this effort using the TXO or TIXO mainframe computer. The TIXO is the legendary machine on which the original hackers of the Tech Model Railroad Club at MIT are using to compute at night. This is how they're learning to compute. This is where almost so much of programming culture comes from, this group of individuals working on this TXO machine. Now, Morse is working in machine language, much of it macro generated. Source code for this project does not survive but these flowcharts do. The flowcharts give a good sense of the program, and I'll show this in just a second. First, I want to mention that Morse is operating on a television production schedule. He's doing very early software engineering on a television production schedule. He has to deliver computer-generated scripts to CBS in 6 weeks, or the network will go ballistic. This is probably a unique software engineering project to this point, given this constrained timeline, very compressed timeline, and that the stakes were so high, this was going to go out onto the airwaves. Back to these flowcharts, I've reconstructed an excerpt for you to check out today. This little segment defines the sheriff's high-level behavior in the story world. First, he enters the scene, then he goes to the window, then he performs the look action, which is a subroutine with its own excerpt in the flowchart. By virtue of performing the look action, he may or may not spot the robber. And then from there, we proceed to this. This is what Ross calls a switch. It's a probabilistic branching point in the logic, and it's what allows the program to produce different stories every time it's run. To decide which way to branch at a switch, the program consults a dedicated scoring mechanism for that switch. In the scoring mechanism, each branch the program could potentially go down is scored according to the state of the story world. So in this example here, if the sheriff has spotted the robber, but not vice versa, then you can see there's about a 10 times, the chance of doing the advance or the other branch are about 10 times as likely as the wait branch. These are all author defined, and I'll get to how that works. It's kind of cool. Get to that in a moment. Let's say that the program decides to go down this branch. Now we've reached a deterministic branching point where the branching depends solely on what is in the robber's right hand. Let's say he's holding a gun. Now we proceed to another switch. This will have its own scoring mechanism. And from here, we'll branch, let's say this way, and we get to the shoot subroutine, another action which will have its own logic in the flowcharts. The flowchart has 3 leaves, which you can see here. And this will give you a sense of the size of the program, the extent of its logic. And that program, by the way, is called Saga 2. Now, one peculiar thing about Saga 2 is the level of detail with which certain actions are modeled. So all of this gnarly logic that you see here is simply so that a character can empty his hand of an object. This is the FlexoWriter online console, a very cool, innovative, influential peripheral of the TXO computer. It allows for online interaction with programs as they're running. And Morse, Dit Morse, the programmer, utilized the FlexoWriter on this project in a very interesting way. In an authoring mode, a special authoring mode, the program will execute as normal, simulating activity in this world, which ends up constituting stories. But whenever a switch is encountered, instead of deciding how to branch right away, using the scoring mechanism, the Saga 2 program will yield control temporarily to a human author who sits at the FlexoWriter. And what this author can do is arbitrarily modify the scoring mechanism by editing these weights. So this is a really cool authoring interface. Effectively, this authoring mode is an authoring tool extremely early. It comes as early as the first system. And this allowed Morse, operating with only 6 weeks of time, to quickly tune all of these weights in an online manner, tune, see what happens, restart, tune again, see what happens very quickly, which allowed him to tune the system so that it actually produced interesting stories by the time they had to deliver these scripts. Saga 2 is specifically a script writing program. So as the program is executing, actions are occurring, the characters are acting in the world, and then it's printing out one line of script at a time, again at this FlexoWriter console. Now, Morse,
Can I ask a quick question?
yeah, go for it.
When you say the script is, this is pantomime, right? So are these like stage directions? What is it printing?
Yeah, check it out here.
Oh,
So
great.
here's an excerpt from one that I found at the Computer History Museum. And yep, it's kind of these stage directions, but they're a little bit weird. So what you see here, it tells the robber to go to the corner, pick up the glass with the right hand, right? And then empty. I can't remember, that has some specific meaning. And then, it's really about all this object manipulation. And then there's things that happen, like here, the sheriff dies because the sheriff must have been shot, unless this was a buggy run. I actually don't remember this specific one. So yeah, the script is pantomime that's being spit out one line at a time on the FlexoWriter console. Now, Dit Morse, again, that's the programmer, he did not have programmer time, and especially computer memory, to build out a natural language generation module. And natural language generation was just emerging with Victor Ingve, another professor at MIT, in 1959, 1960. For various reasons, Morse was not able to produce a full-fledged natural language generation module. So he had to rely on a clever hack even to print out this kind of language. Here's how it works. At any given time step t in the simulation, the story world will be in some state. And then the next action will occur. And then the story world will be in a new state at time step t+1, where that new state has changed by virtue of the effects of that action that was just taken. So Morse's clever hack was to use a kind of bit vector representation of state, which allows for super easy computation of the delta between any two states, where that delta is just a series of bits representing what exactly just changed about the world, which is a way to easily know what should be rendered next in the script. So that delta says what has changed, and then Morse just has simple rules for how to turn what has changed into a particular sentence in a library of sentences that are available. Really clever hack. It basically used like no memory compared to almost any other approach you'd have to do to even get that kind of natural language into the scripts. 6 weeks later, it's the deadline. It's a television production deadline. This is not a conference deadline. This is not a journal submission deadline. This is not a class project for this master's student Dit Morse. This is CBS, right? And it's 6 weeks later and the deadline comes and they deliver the scripts on time. They send 9 computer-generated scripts to CBS along with Ross's sketches. And now it's CBS's time to take on their work. And first thing they do is build out a set. And this set looks just like Ross's sketches, remarkably so. It's really well done. And then they cast the talent. In the role of Sheriff, Halewood Hale Brown, future sportscaster, a sportscaster that anyone over 50, 60 knows really well. I believe he did Monday Night Football for some time. And then in the role of robber, Jack Guilford, at this time a character actor that anyone would kind of recognize from Westerns and other television programs. He went on to be an Oscar nominee in the early 70s when he started doing some work in Hollywood. Guilford in particular is spectacular in his performance. Recall the level of detail with which certain actions are modeled, namely the handling of objects, as you see here. Now, I want you to watch Guilford's performance, and in particular his hands and how he handles these objects, where he's trying here to pour whiskey from a bottle into a glass and then to drink it. And I've got the script actions that correspond here in the bottom right. Notice right here, he has to take the glass from right hand with left hand. And you can see, I might have that slightly off there. But you can see the strange ways he's handling these objects, right? And when you see it in real time, you don't notice it, but when you know how the system works, you're like, oh, he's very conscious about which hand the glass is in, and that he has to first go like this to pick up the bottle with the left hand, which is the peculiar logic of the program being rendered by this human performer in a spectacular way. Now, one fun thing about Saga 2 is that the more characters drink of the whiskey, the more erratic their behavior becomes. This is called the inebriation factor, and it actually affects almost all of the probabilistic logic. How much a character has drank affects how they act, and this can lead to some really humorous and strange stories that are in the possibility space due to this clever feedback loop, essentially, where the more a character drinks, the more erratic they become, including wanting to drink even more. So there's some scenes where the robber is just wasted and wins but can't escape with the cash because he stumbles on his way out of the hideout and things like that. CBS produced 3 little playlets, 2 of which are absolutely remarkable. The first of these is a scene in which the robber strikes the sheriff, ultimately killing him before the robber makes off with the cash. This is, to my knowledge, the first time in television history that the bad guy won. The first time that a villain was victorious in television history. This was possible, this was done because Wolf believed that a machine writer, could not be held to the strictures of the Hays Commission and FCC regulations on what could be aired on television. At that time, you just couldn't air a bad guy winning. Wolf said that only binds human writers. This is a machine. It can write anything it wants and we can air it. And CBS did so. Absolutely wild. Now, the second interesting playlet was the third one they aired. And this is interesting because it's glitch art. This is glitch art. It's a buggy run that they sent off for fun, and CBS loved it and actually produced it. Now, this is 1960, which means there's just 3 television networks in the US, CBS, ABC, NBC. That's it. There's no 4th television channel at this time. This is way before cable, way before Fox, and so forth. That night in 1960, Tomorrow aired on CBS. And it was up against Peter Loves Mary and Naked City. Naked City is a really great show. And it finished second in the Nielsen ratings with an estimated 7.7 million audience homes, which allows us to assume today that at least 10 million people watched these computer-generated stories on CBS in 1960. The next day, newspapers printed sensationalistic headlines and this amazing illustration of the Saga 2 program that appeared in various newspapers across the country. And generally, the reviews were favorable. They liked the Tomorrow program, and they really liked the parts featuring these computer-generated playlets. They thought they were informative and humorous and interesting. But one contingent was livid. At the end of the program, naturally, Thomas H. Wolfe is given writing credit. But so too is MIT Computer TXO. The Writers Guild of America was furious that a computer was listed as having undertaken in their noble craft. And they demanded that CBS, if they were ever to air the program again, would remove the computer's writing credit. To my knowledge, it never aired again. CBS televised computer-generated stories in 1960, and 10 million people watched. I have this little tiny URL that I've set up, tinyurl.com/saga, and there's a -II for Saga 2. This will take you to Tomorrow, which is on YouTube, thanks to MIT who digitized it, and it'll skip you right to the part where you see these computer-generated playlets playing out with live actors for all of America to watch. And that's about 9 minutes. Probably not worth spending our time here. We could. For now, I'll stop and we can jump into Q&A or whatever you want to do next.
Yeah, thank you for that incredible presentation. Do you want to give maybe like a 5-minute just description of what your work has been? We are going to get to, unfortunately, I didn't get to put Talk of the Town on there, but we are going to do Bad News.
That's right. Yeah,
like
that's right.
later. I think it's like after the midterm, so it's a little ways away. But we're going to get specifically into like an emergent systems versus planned stories sort of dialogue. And I feel like you're very firmly in the emergent stories camp. So do you just want to talk a little bit about your work and sort of what inspired you?
Yeah, absolutely. So I do all this historical work, which is about excavating systems. Like this was basically forgotten. I saw it briefly mentioned somewhere with a couple sentences, and then dove into archives and stuff. And there was a lot in this case, and many other systems that I've discovered that are forgotten. So I'm really interested in the history and in exploring that. But as Stephen has just alluded to, I also have a technical practice, and I do technical scholarship, publishing at similar conferences. That's how I know Stephen, to where he's publishing. And in my work, I'm interested in emergent narrative, emergent storytelling, and with a particular kind of flavor. And you haven't got to emergent stuff yet, is that right?
We briefly introduced it when we talked about Tailspin and author. We've talked about some themes that are coming in the course of this, like, you know, focus on realistic characters versus focus on a well-formed story.
Gotcha. Okay. So, well, funnily enough, Saga 2 is an example of emergent narrative, with these characters acting, and then obviously there's human performers and all that kind of stuff. Yeah. So in my work, I'm interested in emergent narrative with a particular kind of spin, which is that I build these worlds that have tons of characters, that have, we're talking hundreds of characters, right? Which differs from all of the existing systems, like in Stephen's work, that are interested in story structure and in producing story structure, generally through settings that have, you know, 2 to 5 characters or something like that, and the characters have specific aims, and then you're seeing how that plays out. That's producing the story structure. In my work, I'm interested in a different approach where there's, say, 200 to 500 characters, and they're living out little simulated lives. And it's happening over the course of a few hundred years of story time. And generally, what characters are doing is boring, it's mundane, it's just the activity of everyday life. But what a system can do is, after an entire simulation has transpired, producing a ton of material expressing what characters have done in that world, then some other system can sift through all that material and say, yeah, 99% of this is really boring. It's just a kind of backdrop. But if you look, there was these events here where, like, this character slighted this character one time too many, and then they planned revenge and they burnt down that character's farm. And then there was this trial that played out, you know, like bona fide, interesting narrative material, but it's embedded in all of this material that's just expressing characters living out their lives in a world. I call that story sifting. It's a big focus of my dissertation and of the technical work I'm doing going forward. And you're going to do a little segment, if I've seen in the syllabus, on story sifting, and read some cool work by Max Kerminsky, who's been working in the same area as well. One project that's my most successful example of that kind of thing is called Bad News, where this small American town's been simulated a couple hundred years, and all of these interesting narrative situations have arisen, have emerged. That's why it's called emergent narrative, just through rules about characters interacting. And then we take that world and produce this installation-based performance with the live actor that's set in that world. You'll get to that later. I'd be happy to talk more about it. I just want to mention it's really funny, because when I went back to Saga 2, you know, we didn't cite Saga 2 because we didn't know about it. But that's totally emergent narrative, producing all this material. CBS did some curation to make it a little bit more interesting and to throw away certain extraneous things, and then humans actually acted it out, which is kind of the moves we pulled basically 55 years later, which is interesting. Yeah, that's kind of an overview.
So I've got lots of questions and discussion points, but I want to open it up because unfortunately we've had so much paper content so far, we haven't had a lot of time for discussion. So I just want to give our students and audience a chance to ask you some questions. And if no one has questions, I've got a huge list.
Cool.
I had a question. So I never really thought about the way that the industry might reject interactive narrative. And I was curious if that, like, because obviously the Screenwriters Guild or whoever it was you said was opposed to that. Has that been a continuing theme, or is that sort of a one-time situation?
Yeah, that's a great question. And unfortunately, my Zoom didn't say who was talking. I just...
I'm Luke.
Luke, awesome. Okay. Yeah, my Zoom just wasn't indicating. Yeah, thanks for the question, Luke. That's a great one. This is a recurring notion if you look into the history, and it's never again, or no one did anything like this where they aired something on television. So that hasn't occurred again until an example that's close would be like Bandersnatch, the Black Mirror interactive narrative, which is, not generative, but it's interactive. But certainly that was written by humans. To my knowledge, computer-generated stories have never been aired again on television in any major way. And so the Screen Actors Guild has been fine, right? They're not worried about this. But where this really connects in this history is that the people that carry out the craft that the computer is now intervening in are outraged, they're threatened, they're very seldom enthused by the computer's intervention in this work. And so like in computer-generated art, you have visual artists who were really bothered by the computer beginning to generate art in the 1950s. And then you have poets who are really bothered by the computer beginning to generate poetry in the 1960s. And it's this interesting mix of, like in the case of, let's say, computer poetry, like that's not poetry. Only a human can generate poetry. What poetry is expression of a particular human soul in the form of material that another human soul can consume and have a sense of what that person, what their experience is and what they wanted to say. And a machine has nothing like a soul. So even if it produces something that looks like poetry, it's actually not poetry. It's not imbued with this special sauce that human poetry is. And so from one sense, they say it's not poetry, but then there's this other mix of like feeling threatened in the sense of, their job is going to disappear. There's always been paranoia, and there still is, about our AI or just computers generally stealing jobs, including that of the poet, which is kind of a quaint thought, I think. So yeah, the big takeaway is humans who carry out crafts have always been bothered and continue to be by humans who participate in that craft. When it's just any job, but especially when it's something that we felt like was sacred to humans. And things like poetry and narrative are things that humans conceive of as the very things that make us human, which I think is true. I still think it's really interesting that a machine could produce these kinds of artifacts. And then ultimately there's humans behind the scenes that are creating, right? So Ross and Morse created Saga 2. They were the authors of the platelets, especially Morse, who sat there tuning all these weights with the FlexoWriter. He's the one who crafted that possibility space. There's a machine there, and it's really interesting that the machine's there, but there's a human behind the scenes. Yeah, thanks for the question.
Yeah, thanks for the answer.
Yeah.
I don't really have a question, but a comment on what I thought was interesting about Saga 2 was we kind of think of these computer-generated stories as the author does the high-level, broad-stroke stuff, and then the computer simulates from that point. And this is kind of the reverse, like the computer is doing the broad strokes, and then the humans are simulating those actions instead.
Right. Yeah, thanks, Ryan. No, you're absolutely right. I think there's a whole design space on computer-assisted performance, and we can specifically say AI-assisted performance. And I've attempted that with Bad News, which by the way is a collaboration with Adam Somerville and Ben Samuel. I'm super interested in that design space, which was really invented by Saga 2. I've since found later stage plays that were computer generated and actually performed, but totally in the avant-garde, not for 10 million people. So yeah, I think it's a really interesting inversion. it's an interesting labor breakdown that tends to invert the typical breakdown of labor in human machine collaboration. Here the human performs what the machine produces, and typically the human's producing something, defining a simulation, then the computer in a sense performs it. Or say, NPCs in a video game who are carrying out some particular narrative, be that they're moving about the world or delivering content. Here you have humans that are performing. Yeah, absolutely. I think that inversion is radical and really interesting, Ryan.
Would you say, just from a technical perspective, it struck me that what they designed is basically a Markov chain, right? And it's hierarchical, which I think maybe was hierarchical just so they could draw it on printer paper.
Right.
But you could represent it as a Markov chain, and it had with this interesting caveat that there's a human tuning the weights as you're playing. And so the human is really actually doing some search, kind of like it's basically a human expressionist, if you think about it that way. Like the human's kind of like exploring this Markov chain, which sort of is maybe spiritually similar to a grammar, but trying to like make, like, fudge the dice to make certain outcomes happen. I don't know. Is that a reasonable description?
It reads to me in one way, but not in another. Certainly there's a kind of sculpting, right? And that's what my simulation craft feels like. It feels like sculpting. Of course, I set up all the initial rules and stuff, and I start getting a sense of what's there, and then I'm tuning, but really I feel like I'm sculpting the possibility space. And it's like, oh, I don't want stuff like that, so I'm going to try to prune that part of the space and constrain things and bring it in here. And it's like, oh, this is interesting. I never even thought of that. I'm going to make it more likely. And now it's kind of blooming. That part of the possibility space is mushrooming out a little bit more. Kind of sculpture is the feeling, and I would assume that he wouldn't use that language, but Morse kind of felt like I feel, however you articulate that. I don't think, Stephen, that I wouldn't say Markov chain for one reason, which is that it's tracking the state of the story world. And so what happens next is not in a Markov chain, typically what happens next is following from the previous item or previous two or previous three, but you don't go back farther because of data sparsity. There's just, there's never been this 6-sequence thing before, or there's just been one and now we produce what exactly followed it and you're just recapitulating the source data. So here it's, what happens next is probabilistic like a Markov chain, but it's a result of the state of the world. And so you can have things that happen way at the beginning of the story. Now you're 100 actions later, but that thing at the beginning did affect the state, and everything's always branching according to the state. So from that standpoint, it's more dynamical and computational than a Markov chain. It's more like,
maybe more like a behavior tree.
Yeah,
some probabilistic branching.
Yeah, a behavior tree is probably the best. This maybe is a behavior tree. Maybe that's just the way to think of it as far as how it's used. Behavior trees and how they exist now in a video game sense.
And they even modern behavior trees even have that, like, okay, jump to this other behavior tree or this other state machine or something. Which right. So, it looks like this guy sort of basically invented behavior trees. Actually.
Yeah. Wow. For some reason I haven't thought of that, and I've been in this material so much. I think you're exactly right. I think that's the best way to think of it. It's a behavior tree in 1960. And maybe it differs a little bit, but conceptually the same. And you have things like modularity and reuse through calling subroutines and so forth, which are some of the benefits of behavior trees. Yeah, that's cool. I know like Michael Matias, they use behavior trees in Facade, and behavior trees work their way into AAA games and AA games, but not so much yet. And he's always decried how like games is like literally, because those came out of the 80s and robotics actually, they're like 40 years behind. It's like, no, if they came in 1960, these video games are trailing by 60 years, what MIT has been up to. I'll say one more thing about the code and just more about the code itself. This is machine language. And it ended up being 13,000 lines of machine code. which I think something like that was the biggest program ever produced at MIT. But to produce it, R Morse, the programmer, the master's student, had to basically invent macro generation, or like completely progress the state of the art. So macro code, where you have some code that generates more code and you can bootstrap and stuff. He basically like invented that notion in these 6 weeks because he just didn't have time to write out all the code he needed, and was thinking, how can I write less code that produces, like, was just thinking in that space, which produced this macro generated code, and that notion, which completely advanced compiler theory in the 60s, and like major advance in software engineering, just because he only had 6 weeks to work. So the TV production schedule ended up being important in the history of computing, which was interesting.
Jeremiah, I saw you had a question or comment.
Yes. So you mentioned, I think, that the particular type of emergent storytelling that you're interested in, did you refer to as story sifting? Okay. So it's interesting to me, and I'm wondering if anyone has thought about, or if you think it's plausible that you could potentially sort of zoom in and out. Instead of dealing at the level of people, you could be individual people, you could be dealing at the level of groups of people, and you could possibly generate long historical narratives on the basis of the same kind of idea.
Yeah, you're speaking my language, Jeremiah. Absolutely. Yep. How I conceive of it broadly is you have a simulation, it produces a ton of simulated material. Embedded in that material are subsets, collections, event sequences, other kinds of groupings of material that have a narrative charge when a human looks at that material. One thing could be stories about individuals carrying out actions, and those actions cause other actions. Of course, there's a temporal sequence, stories at that level. Other things are, there's these groups of people, there's these organizations, there's these rises and falls of things, taking more of the genre of historical narrative. Totally. Yep. I'm absolutely interested in narrative broadly construed in this sense. And there's actually an interesting connection to be made to nonfiction, I think, where increasingly, like, journalism just works like this. You have all this data describing real events. How do you find the stories, the narrative material in all of that material describing real events? That's in very broad strokes the task of the historian. It's the task of the journalist, where, of course, the stories pertain to real events. And increasingly, this world is just producing a ton of data describing real events. And so it seems like something like story sifting, that technical approach, could actually be applied, strictly in a nonfiction sense, and even in a very conventional nonfiction sense, like in the task of journalism.
There's there was actually writing about this at my undergraduate degrees in history and classics, and there were for all the sort of idea that that history as narrative comes from postmodernism. Actually, there were historiographers who were talking about this in the 19th century, actually, who were making the point that you're always, as a historian, you're always selecting particular events out of many events that happened, but you have to decide which ones you think are significant to talk about. And in a sense, that's kind of a human doing that sort of story sifting that you're talking about. But this is interesting to me also from a fictional perspective of things like some of these science fiction writers from the 20th century, like Isaac Asimov or Olaf Stapledon, who are doing these extremely long future sort of histories that, like I think in Asimov's Foundation, they don't even remember what planet humans came from. So it's so far in the future, they don't really know what Earth was. Right. But there's obviously some limitation to what an individual person can do, and maybe this provides a tool for creating narratives that an individual wouldn't think about, I guess.
Yeah, awesome. So you get 2 points there. I want to touch on the first. In my thesis, Hayden White is maybe the biggest intellectual influence. And for others, Hayden White is a historian, a historiographer, famous monograph called Metahistory, I think in 1971, which is a history of history writing, a historiography of historiography itself, hence metahistory. And he really emphasizes, apparently building off work from earlier folks in the 19th century, as Jeremiah just said, he really emphasizes that the act of historiography, of writing down history, is essentially an act of curation, of selecting material, of placing it in particular frame structures that are narratives. And you have to put them in a narrative structure because that's what humans need to be able to understand the world or what someone's saying about the world. And so the act of history writing is not just writing down events faithfully, which is impossible, or meaningless, because then it would just be names and dates and it wouldn't affect anybody. It has to be a narrative. And anytime you construct a narrative, you're deciding what to put in it, what order to tell it in, how to charge each of the elements rhetorically, and so forth. So Hayden White, who was actually at UC Santa Cruz, he's passed away now. I never met him or anything, and my advisors didn't even meet him. But he's kind of in the air there up on that hill. Hayden White was the biggest influence intellectually on my thesis, and he recurs all throughout it. And so my move, in a sense, was to take Hayden White's curation-oriented notion of history writing and bring that into computational narrative, and think of a curation-oriented notion of story generation. And to curate, you need lots of material, and so that just fit nicely with the emergent narrative paradigm, where it's typically producing tons of material. The thing that I was really working against, which I probably should have mentioned, emergent narrative is a bad rap, rightfully so, in the field in which Stephen and I, and increasingly you, operate. And I had this whole account of why I think that is. And generally, the move in emergent narrative typically was throw some characters in a simulation, have them just do stuff, and then at the end, cool, we have stories, right? We have a story. It's everything that happened in the world. And generally, 90% of what happens in a world, even if you have a lot of characters, and maybe especially so, is boring. And that's not the story. You actually need to do curation to produce things that are in the frame structure of recognizable narrative, where humans would say that has the frame structure of narrative. And that hadn't been done in emergent narrative in our field. And so my thesis is like all about emergent narrative, but actually kind of operating against emergent narrative, and then like breaking down the whole enterprise and then trying to rebuild it. And the way I try to rebuild it is with Hayden White. As far as your second point on these sci-fi stories that are really these kind of grand sweeping narratives about fictional worlds that take place over huge periods of time, I love those kind of stories. I love generational narratives. I love stories that just articulate over long periods of story time. So that's something I'm totally interested in. And again, that's why I simulate my worlds for hundreds of years and then start sifting out material, because you can get stories that take place over long periods of time, which I think is really interesting, and which hasn't really been done yet in story generation. And I'm trying.
I just want to say that Hayden White also, I read some Hayden White when I was an undergraduate, not because I had to in any class, but basically because I was always interested in this topic of specifically writing history, because
yeah,
you can approach history, from the perspective of reading about history, but that's not really what historians do. So I was always kind of interested in this theory of writing history. And so, yeah, I think that's very interesting that he inspired your work.
Awesome. Yeah. Check out my thesis if you want. And it's very big, but Control F for Hayden White. And maybe those will be the parts that
We'll do.
Yeah. Thanks so much, Jeremiah.
Yeah. So James, we're getting to the end here, and I don't know. It's 11:50. If you need to go to your next meeting or class, I don't want to keep you. But if you could stay for 5 more minutes, I just have one sort of prompt for closing comment.
Yeah. Awesome. Yeah. Let me just make sure I know my wires crossed, but I believe everything's just when Google tells me to do it. Yeah, I have till 11:10. So.
Oh, great. So what?
My time, obviously. Yeah.
especially like your work, which takes us so far back and realizing like, wow, so much was happening earlier and it was more advanced than we thought it was. I feel like so many people thought Tailspin was the very beginning, and then, you're showing no, it goes back even further and it's surprisingly advanced. Like, you can look at our field and feel really depressed and say, we've made so little progress in 60 years. But you could also look at our field and be so excited and say, look at all the incredible stuff we've done in 60 years. Like, could you sort of reflect on that feeling of how far we've come and yet how far we haven't come?
Yeah, that's a great question. It's not quite accurate. This field has a 60-year history, but after Ross and Morse created Saga 2, they never worked in this. There was no field, and they didn't work in it again. Somebody else came in 63, Joe Grimes. I wrote a paper about that. He had a story generator. He didn't know about Saga 2. He happened to not watch CBS that night, apparently. He did this thing. He abandoned it. Someone in 1969 did a similar thing. They didn't know about either of the two before. Sheldon Klein came in the early 70s. As far as I know, he didn't know about any of these. Meehan, finally, there was someone who knew about something before. Meehan, who did Tailspin, knew about Klein, but in my opinion, he misunderstood it. And so it's just kind of, really this field took off with Joe Bates in the Oz Project in the late 80s. And then beginning around 1995, you actually have conferences. There's, AAAI Symposium on Interactive Storytelling in 95, and then you have 1999, the Narrative Intelligence Symposium, and I know you're reading about that. And then you get AID in 2005 and iKids and its predecessors around 2000. Really, I'd say this field is 20 years old with sort of scattered work throughout, but people really actively being in dialogue and meeting and caring about narrative, not just caring about what narrative is an application area. I don't think Roger Schenk cares that much about story generation or anything like that in his group. And Meehan, they were interested in planning as a model of human cognition. And so they were exploring planning itself through this. I know you're really interested in planning, but you're also like deeply interested in narrative itself, right? And so, what I get depressed by is the work being forgotten, and then you dig it up and it's like, whoa, this is maybe behavior trees straight up. And if people just would have known about this the whole time, we might have gotten farther. But I think there is something to be said for revisiting old ideas with new mindsets and with new material context. We have so much more memory and faster computers and stuff like that. I'm excited about the field. I don't feel like we haven't made progress. I feel like there's this space and we've really just been exploring it, and it makes sense to go back to parts and look around for a second time and so forth. That's kind of how I feel. How do you feel? What's your answer to that question?
Oh yeah, I don't know. I alternate between it. Some days I think, wow, it's so cool to be working in this area, and then some days I look back and say, what have we done since Facade? And so I don't know. What do you think is next? 5 to 10 years from now, what do you think's gonna? What would you hope would happen? So
I'm interested. Let me just say for AI. I love GoFi and symbolic AI like you do, right? But and I don't know where you fall on this. I'm super intrigued by. Oh, it looks like my camera died.
Yeah, we lost your video.
Yeah, I don't know how my camera can die. I'll just
That's okay. We can still hear you.
Okay, here's my other weird. My one that the better camera died. With AI, I'm super intrigued. So I love GoFi, I love symbolic AI, I love planning. I'm super excited. I love grammars, right, as you know. But I'm excited about stuff like GPT-2 and neural networks and where that's headed. But I don't think that's ever going to give us the authorial control that we know and love with our fabulous GoFi techniques. But I'm super interested in hybrid approaches that combine the strengths of both, the complementary strengths and combat the complementary weaknesses. So generally, I'm just excited about possibilities there. And I think there's so many for interactive storytelling. And actually, in the work I was doing at BBN, we were looking at combining expressionist like grammar-based text generation with stuff like GPT-2 and seeing how can you trade off between them in ways where you produce cool text you couldn't produce otherwise. I think in narrative, there's options like that. And, Mark Riddell's going really far with neural networks. To my knowledge, he hasn't really got back to his roots and looked at how you could cross-pollinate and things like that. So I'm super excited about that. Another thing I'm excited about is human performance and computer-assisted performance, like in Bad News and in Saga 2. I think we're going to go to cool places soon. Yeah, I'm optimistic about the field.
Great. Well, okay. Thank you, James. We're a little over time, so I think I'd better let you go. But thank you so much for coming and giving this really fascinating historical talk and your own extremely knowledgeable reflections.
Awesome.
And I can't wait till we get to some more of your papers later in the semester.
Cool. Awesome. Thanks so much. Pleasure to be here. Great to see you, Stephen. Can't wait to have a beer with you in person sometime soon.
Yeah.
And if anyone wants to reach out, I'm easy to find. jamesryan.world is my website. Otherwise, you can find me.
And it is a pleasure to peruse as a website. You can get lost in James's website.
Thank you, Stephen. All right. I'm going to check out your YouTube channel. All right.
Oh, thanks. Yeah, you'll be up on it soon.
I'll be up on it soon. Yep. All right. Goodbye and take care, everybody. Thanks so much.
Thanks, James.
Thank you.
Thanks.